I'd like to welcome representative of RemSense, Rory O'Connor, RemSenses product manager. Going to talk to us about next-gen decommissioning, leveraging high-resolution visual reality for efficient operations. Over to you, Rory.
Thanks very much. So, as the title suggests, I'll be discussing some of the technologies that we've developed and use at RemSense, specifically focusing on the high-resolution visual reality that we capture. So, I won't rehash a lot of the challenges that this technology faces that have already been discussed here today, but just to touch on a few of the high-level challenges of decommissioning, which are addressed or should be addressed ideally before the stage when an asset is abandoned and requires a lot of the scope that has been discussed in previous sessions here. So, assets that are still operational but have had life extension programs pushed beyond what their original planning was for need to be managed in a way so when that handover occurs, it's done in a responsible way so that the issues of things like contamination can be avoided, so that structural integrity has been preserved. There are economic and strategic planning factors that need to be addressed here. A lot of this comes from addressing the tension between shareholders and owners in trying to extend and milk as much of that asset as possible before the point at which it becomes untenable, and managing the environmental risks of continuing that asset's production. All the while with an aging asset, operational inefficiencies, specifically for older assets, come into effect as well. The reality modeling that we demonstrate with our product virtualplant is intended to facilitate these remote modeling, planning and analysis exercises, ideally to reduce the headcount on site for continuing to operate assets, and facilitate the planning ahead of the decommissioning activities that are scheduled to go on in advance. Often it's the case that there's a lot of tension in getting people on site to be able to carry out this kind of survey, this kind of data capture. So it's key that we can capture and deliver those insights, distribute them worldwide through a web application, as we have with virtualplant, so that as many stakeholders that are crucial to that process can be engaged as early in advance as possible. This isn't just a single capture process as well. We don't just go to site, expect to capture the visual scene once and then hand it over. We understand that these are scenes that are constantly changing. They're assets that are undergoing potentially late life updates where new infrastructure is being continuously installed. Maybe the maintenance systems haven't been updated, and there needs to be a way of visualizing what's actually there on a frequent cadence to be able to address these challenges. In addition to that, as has been stated before, a lot of the structural integrity and a material integrity of these assets is, as it begins to decay, might be overlooked, and it might be changing at a rapid pace. So the means by which assets can be visualized on a frequent basis, externally and internally, are key to be able to remediate these issues. So what we cater for is to be able to deliver a 360-degree visual interface that lets our customers understand exactly what is on site. We capture this with high-resolution imagery, and we pride ourselves on being able to capture the highest resolution imagery year after year as that technology continues to advance. With the benefits of this high-resolution imagery, we also try to deliver as many of the insights that can be derived from that as possible, leveraging AI applications, which I'll discuss in the following slides, for two key applications that are very relevant to decommissioning: asset identification and recognition. So assets that may or may not be actually tied to a customer's computerized maintenance system. In addition to that, corrosion detection, which traditionally is something that has to be carried out by boots on the ground on site, which represents an enormous cost and can be the consequence of a big time delay as well in being able to capture those insights and turn around a solution to remediate those issues. So this is a scene from our virtualplant application. You can see we've got captured very high resolution imagery, and this particular scene has been tagged up with assets that have been identified completely using artificial intelligence. what we do is we can attend site, again, at a very frequent cadence, and we in fact enable our customers to be able to capture data themselves to ensure that we get a regular update of data to reflect what's up to date and consistent with what teams have to deal with on site at any time. Immediately, as that imagery is processed, and this is happening while the team is still on site, we can capture and extract any instances of text that align with nameplates. We can correspond and cross-correlate those with asset identification or asset maintenance systems and pick up and identify all of the assets that have been computerized in an existing system. In addition to that, we can also extract out regular expressions and understand the patterns of those strings of text to be able to find assets that haven't been included in the asset management system. In one particular case, one of our customers in the Northwest Shelf understood there was a problem with assets inside one of their offshore platforms that didn't exist within the maintenance systems. These are critical maintainable assets that need regular maintenance work. There needs to be an understanding of what the model is, when it needs to be updated, when it needs to be addressed. And there was this big problem as different contractors come on site, they install the systems, and maybe within the context of multiple different maintenance systems, the information just gets lost. So what we've been able to do is capture and identify unregistered assets in addition to the registered assets, and to be able to deliver that back to our customer. Again, while our team is on site, this is all happening effectively in real time, and be able to give them the insights to understand how they can continue to maintain and manage those assets. So another very practical application, which is cutting edge nowadays, is leveraging the high resolution imagery to identify defects such as corrosion and rust. So this is particularly concerning for offshore assets. In this case, what you're seeing is, again, a scene from our virtual plant application. You're seeing very high resolution imagery where there's some obvious corrosion and rust. Traditionally, this kind of issue would be remediated by a characterization and identification of a team who have to manage to go to site, to walk through the plant, identify and mark up where these issues are located, demobilize, plan the work around it, and a lot of time has to be spent and really wasted in carrying out that process. With the up-to-date imagery that we constantly can provide, this kind of exercise can be carried out completely remotely, and in fact is carried out remotely with all of our clients that have access to this data. With this, they can scale up their teams to carry out this kind of work, but it still takes time. And so we identified a key improvement upon that process by being able to leverage AI and find all of the instances of, say, corrosion and rust that need to be addressed, be able to present them with high confidence from the most severe down to the least severe, and give the user the ability to just quickly click through, find out which ones need to be addressed of the utmost concern, and start the work in preparing those work orders to remediate that issue. We also understand the value in having connections between these types of platforms. So our platform, virtualplant, is essentially a visualization platform, and it's just a simple fabric between the customer and their asset to, as we say in our company, to be able to be there without going there. It's a model, but in addition to that, it can tie in with any other kind of computerized maintenance system, or even IoT and SCADA data. So those kinds of systems have been around for a while. People are familiar with using them, but often the interfaces, though they can give you the data you need, they might not give you the visual environment and visual context to be able to make the decisions that are required to understand the problem. One of our customers had an issue with a piece of equipment overheating, and the solution ended up being just to put a shade cloth above the equipment so that it wasn't in direct sunlight. And without having someone attend site, just the visualization of this kind of system was sufficient to be able to tie the IoT data and the insights that were derived from that with the environment, the physical environment surrounding the asset, and make a really quick and easy decision to understand how they can fix that issue. In addition to IoT data, things like manuals, documentation, very easy to be able to lose oneself within the multiple different systems of record, but having a centralized location that all of those systems can access through, which is, again, a familiar system where it looks exactly like you see on site, has been of the utmost importance to our customers, again, in being able to guarantee fewer people on site and to be able to plan ahead for these kinds of activities that are required for decommissioning. So I've discussed a bit at a sort of a high level what kind of tools benefit the industry in this way. Essentially, as I said, it's all about improving efficiency of operation, reducing the number of people who have to be on site, and being able to scale up teams who have to carry out planning work on site. So for decommissioned assets that have been completely abandoned, obviously there's no one on site anymore. But for assets that are leading towards that point, one of the key strategies identified by recent reports such as those of McKinsey & Co. Are that we need to start scaling down the number of people who have to attend site and to be present on site. And so having a visual system like this prevents not only the number of people who have to be on site from being so high, but also the number of campaigns to attend site, demobilize, and be able to turn around a kind of maintenance campaign very rapidly, like I'm about to discuss. So what I'm going to discuss now is a case study for a tool that we developed in partnership with Woodside, one of our customers. And this was for the fabric maintenance team on one of their offshore Northwest Shelf assets. Again, the previous way of carrying out this kind of fabric maintenance coating remediation work would be to attend site with ideally as large a number of team as possible, but seats are very limited, so it ends up being fewer people. And that takes longer for this process to happen, where they work out where the key areas of impact are, how they're going to address those and remediate those before coming back to site. So they were already using our virtual plant application to carry out all of that scoping work remotely. But the work that they need to do is characterizing these kinds of defects with a complex set of standards and procedures, and often this is carried out by contractors who are brought on board, have to quickly upskill and learn those particular ways of doing things, and it's just not efficient, having to learn that each time with a quick turnover of staff. So what we were able to do was completely digitize their workflow, carry out all of that characterization work within our own application. And this is something that we can quickly configure for other customers, for other types of procedures that need to be carried out. Sometimes it's just a once-off procedure, sometimes it's something that might be ongoing. But to be able to see within the visual fabric of the asset what needs to be done, and then to describe how it needs to be done, is something that has we found has saved an enormous amount of time and money for those customers. And it rapidly turns around that piece of work so that they can move on to the next thing and curtail the overall expense and costs there. So in conclusion, I hope that I've kind of explained some of the key benefits of, in particular, high-resolution visual imagery in addressing some of these challenges. There's lots of different methods by which visual imagery and modeling can benefit these kinds of customers and to address the challenges posed by decommissioning. But two of the key things that we strive to be able to deliver is very high resolution imagery and recapture at a frequent cadence to ensure what they're seeing is kept up to date. Overall, what the impact is that we can inform customers to be able to plan ahead, to ensure that the handover for aging assets into the decommissioning area is done responsibly with a strong commitment towards HSE, environment in particular, and so that the people who are lumped with the responsibility of actually pulling these systems apart are given something or provided with an asset that is has been maintained and has been cared for and isn't been left in a state where maybe they don't have any visual understanding of what's really there. So yeah, in conclusion, that's a quick insight into our virtual plant product. Is there any questions?
Thanks very much indeed, Rory. And are there any questions for Rory on the basis of what you heard, more data and different ways of looking at it?
Rory, how quickly and easy is it for you as a newcomer to be able to make use of the information that's obviously someone like Woodside has been very used to using, But if you're a contractor just coming in for the first time, how easy is it to actually adapt to be able to go in and seek out information?
Very quickly. So that's one of the key drivers of our product. We don't just want to be able to get something in the hands of the customer in maybe 6 to 8 months and be pushing the horse down the cart that way. We can deliver the application itself within a day. We can deliver the data that's being captured while the team is still on site. In addition to that, all of the AI insights. So we don't want to be making them have to wait for that. We can prioritize areas that they know of concern, so they know and have confidence in the information that they'll be able to get. Say, within a week of us mobilizing, they can plan ahead for having that data in hand. And then in addition to that, we can, with our very efficient capture processes, capture an entire site very rapidly, and then that affords the customer the opportunity to recapture, again, at frequent cadences as well. So yeah, we sort of pride ourselves on being kind of like the Ford of the industry. We want to be able to spin out instances, spin out applications, don't make the customer wait, and we understand the benefits, both financial and of efficiencies of being able to do that.
Any other questions for Rory? If not, it remains for me to thank you very much indeed, and thank you to all our speakers in this session.